Okay, so I forgot a part, guys. Sorry. So some of the students, right? Some of the students in the groups, right? Some students they have asked like how to do conversions. How can we study organic? I think organic is getting hard. How can we base them up? So it's like this, students. Like this, right? Organic chemistry, right? It has around 4 units, right? We have hydrocarbons, IUPAC naming. Then you have nitrogen base, then oxygen base. Then we have uh, with the benzene and all, we have certain separate. We have clusters there, right? We have a cluster. So see here, I mean, so 3 units here, right? We have 3 units. So it is actually like there are lots of subunits, right? But they have given based on the reactions at all. Nothing bad in it. There are lots of subtopic which has been hidden within the unit. Right? Within unit, there are certain subheadings which are hidden in it. So in that case, we have the reactions based on the hydrocarbons, oxygen-based compounds, nitrogen-based compounds, and within these people, that within these people, we have to find out the acidity of the particular compound, basicity of the particular compound, whether does it reacts with a base, whether does it react with acid. So those concepts are there. Then we have to study about stability, how to find out the stability of the compound, whether this compound is relatively acidic, does it form uh, certain other compounds, like if you talk about aldol condensation, does ketone and aldehyde react, but are the products forming within the ketones, within the aldehydes? Does benzene has, and also there are lots of concepts going on here. So it's not a simple thing. It's once you study organic chemistry thoroughly, it is very easy. Nothing is you. It's like you will be doing every day organic chemistry. That much interesting subject, very fun. Nothing. There is nothing to do in it. If you can understand the concept, if you can remember the conversions which is going on, directly you can do the sketches here. So since you guys asked me like how can we approach and do conversions, how can we study, so once you're asking about the study parts, I will say you a very good method. First thing, take your resource book, go through all the reactions what all you have, right? So if you take hydrocarbons, take the hydrocarbons part. For example, let's say alkene. So let's say if we take alkane, we have two types, right? Right, one we have combustion. So in alkanes, you have combustion with oxygen. So in that we have balancing part. That no need. We need to know only the conversions. Second thing we know, that is using the diffuse sunlight. Right? By using diffuse sunlight, you are going to fit the halide to the alkane there. So in that, there you have two reactions. You take a summary. Right? You take a summary, like for example, if you take alkane, students, if you take alkane, right? If you take alkene, you have two types of reaction here. One you have is combustion, right? What you have is combustion. Just keep an example like CH4 takes oxygen, goes and gives carbon dioxide and 2 moles of H2O. Then you have halogenation. So, so you have halogenation. So let's say, for example, CH4, once you, during the conversion, if you add bromine with H mu, or you can say diffuse sunlight gives CH3Br, CH3Br plus HBr, right? HBr. Same way, if you add excess, right? This is another case. If you add excess, you add excess BR2 with H mu or diffused sunlight, diffused sunlight, we have C BR4 plus 4 HBr. Right? So we have these kind of reactions in the halogenation part of alkene. So this is the reaction based on alkene. Right? This is the like this is how I have studied. Right? I don't know about what other cells are doing. I studied in this method. Right? This is the best way. So the best way to study is like this. Okay, you got the reaction. So this is reaction. No, this is reaction side. Right? Take a piece of paper. Take an A4 sheet, foolscap paper. Fold it into half. Exactly half. Right? Exactly half. Then in the middle, after opening, like let's say you took the sheet. Let's say you took the sheet. You fold it into half. So in the middle. So in the middle, you write this alkene. Here you write the reactions based on this, right? Reactions. Here you have to set right production method. Right? If I say production method, you have to understand, guys. It's like this. Production means from which compound you can produce alkene. Understood? For example, if I know the reactions thoroughly, right? If I know the reaction thoroughly, if I use Clemmensen reduction method, right? Clemmensen reduction reagents, right? Clemmensen reduction method. For example, let's say this is there only for alkene, I mean ketones and aldehydes. So if you add zinc amalgam con HCl, right? Zinc amalgam con HCl, it gives CH3, CH2, CH3. So this is alkene. Same way applies for aldehyde. So CH3, C double bond of H. So zinc amalgam with con HCl gives CH3, CH3. So this gives alkane. So this gives alkane. So like this, there are set of reactions here. Okay? There is lots of set of reactions here. Same way if you take for alkenes, there is lots of things. So if you are able to take a whole summary, first thing, read the resource book. First thing is first, read the resource book. Okay. Read the resource book. Get the summary of the reactions. First take a rough sheet, take all the reactions, whatever you have. Whatever you get, take the reactions. Then bring it aside. So after that, within those reactions, check for each of the following functional group. How can we produce them? So take that summary. So conversion side is going to get over. Okay. So that short note is fit for what? For the conversion side. Okay. That is a side right now. Okay. Now, for acidity basicity, it's a theory part that either I have to explain by doing questions. It's there mostly in the MCQ parts. If I have, I mean, I'll maximum try to do my best to get the time by finishing all the structures and essay part and the past papers and all, and we can inaugurally we can start the MCQ parts very early. Right now we have started around 7 months are there, if you're including this month, so nearly 7 months are there for the exam. So we'll try our maximum to finish the essay parts in 3 months. Then in next 3 months, we will try to do our maximum to finish the MCQ part. So MCQ part is the most important part. In structure, if you leave a huge part, there's not going to be an issue. But easy part, no. Leaving is your careless mistake, right? It is going to be your mistake. that you should have studied in time. So you can gain marks easily in the essay side, but in MCQ side, if you take 1 mark, let's say if you lose 1 mark in MCQ, in the essay parts and structured essay, you have to gain around 20 marks to equalate that 1 mark. So MCQ is that much important. If you are able to score in organic and all around, like, let's say around 12 or 13 MCQs can come, right? Very much easy part. If you are able to score all those things, you can get a huge difference in your Z scores and all, right? In your marks, in your grades and all, you can get the higher Z score range in the chemistry. That's how the MCQ plays a major role in your results. So if you take a summary like this, your conversion is going to get over. Facility, basicity and all, you have to, like, I have to explain it through the theory. It is easy also. I think there are some parts in the resource book also, right? That is also there. Next thing is, you have to take the reaction mechanism into another separate site. For alkanes, you have this halogenation. For alkanes, you have this halogenation. For this halogenation, take another step, right? Take in another way. Then take for alkenes, we have hydration, halogenation, hydrohalogenation. So we have another case. In alkynes, we don't have very much newly details or something. We have for alcohols. Like that, you have to continue for until OH. So what all reaction mechanisms are there? Bring it to a paper. Bring it to a rough sheet paper. Right? Keep it carefully. Once you're going to do the past papers, keep them near with you. And then what you have to do? Just try. If they ask for what all methods, try and do it. Right? Just like open book method. So I'll teach you certain methods how to do it. So I'll give the basic part. So this is just a given conversion from the year 2002. Right? I'll give you how to solve this up. Right? I have certain tools with me. So I'll share it to you. So those who wish to follow up the organic classes also can classes can also drop me a message. So I will enroll you into the group, and there is going to be a special discount for the upcoming month also. So don't worry. Try your maximum to join the class and get benefited out of it. Okay, guys. So I'll explain you. I'll be explaining you this part here. Okay. Okay. Now see here. Now this is, we don't know the initially starting product here. Okay, we don't know the initial starting product. They have given the intermediate products here, and they have given the final product here. Right? There are certain methods. Right? Now see here, ma. Now see here, okay. The thing is like this. Now here, either two types of double bond formation can be seen. There are two types of double bond formation that can be seen, right? So I will explain you, right? Now see, now I need to bring this particular to this here, right? Now I'm going to think here. I'm not thinking this side, right? I didn't bring my head to this side. I'm going to think only this side first, because this is easy now. This side is easy. This is a way to analyze. Okay, take the easiest part. Take the easy part. Check the functional groups. Check which method is better. Okay. Now see, I will give you all the methods here. How can we derive? But one thing, which one will suit here will be the best, right? Otherwise, you won't get the marks for this kind of steps here. This is coming in recently also into 2023 also it came 2022. So in those who but wrote the wrong reagents in the wrong arrows and all won't get marks. So see here. So for forming double bonds, there are two methods. There are two methods. So let's say if there was CH3, CH, OH, CH2, CH3, right? And here what happened is, what I can do, I can dehydrate. This is dehydration reaction. So with one H, right? Here one H is there. I can remove this hydrogen, right? I can remove this hydrogen from the double bond here. I can break and form a double bond here. So what I can do is, I can use a reagent con H2SO4, right? Con H2SO4, and I can heat them up. This is one way. Or I can use aluminium oxide and then heat them up. I can use either one of the two reagents. That is not a problem here. I can use aluminium oxide, and if I heat them up, I can get this product. If I use con H2SO4 and if I heat them up, I'm going to get this product. Right? So this is one way of getting this particular product. Now see, you have CH, CH2, CH3 here. Okay, you have this compound. Now here I have bromine. Okay. Now to eliminate this one of the hydrogen in this group, I can use alcoholic KOH. If you know the reagents, you can use it. Right? If you know the reagents only, you can use it. So this HBr is removed in the base, like on the other side, right? Now see here, I'll explain you. Right? I'll explain you. You can ask me, why didn't this bromine go with this carbon? Why it went with this carbon? Right? You can ask this rule. There are certain rules in the organic chemistry while doing conversions. That's the must. We have a scientist, right, who said, once you are adding, let's say if you're adding water to a particular compound, so in that case, the person whom you're going to add water has to go to the carbon which has a higher amount of hydrogen. For example, let's say I have CH2 double bond CH2. I'm going to do CH double bond CH3. So if I put the con H2SO4, let's say dil H2SO4, right, and H2O. If I put dil H2SO4 and H2O, right? Here now I have to do, but what will happen is, I have to put an OH, right? I have to get the final product as a stable product here. See here, the OH has to come either to this carbon or this carbon here. Understood? This OH has to come either to this carbon or this carbon here. So the scientist said, so in water actually we have HN and we have an OH here. So this OH has to come either here and this has to come either one of these two carbon. So the scientist said, which carbon possess the highest amount of hydrogen, there only we have to add the hydrogen. Understood? The carbon which possesses the highest number of hydrogen, to that carbon only what we have to do? We have to add the hydrogen there. So this scientist's name is Markovnikov. So with the name itself, they have given the rule Markovnikov rule. So he proposed that if between these two carbons, when you need to add a hydrogen, right? When you need to add a hydrogen, or once you need at a hydrogen or halogen or any case, yeah. Find which of the carbon has the highest amount of hydrogen among these two. So we know this one has the highest amount of hydrogen. Okay, so it has to come like CH3 CH plus CH3. So this H has gone to this hydrogen here. So this OH, this remaining OH has to come here. So this is what Markovnikov said. So the carbon which has highest amount of hydrogen will come here. So I'm explaining certain rules here, okay? Same way is the opposite for elimination or dehydration. For both the cases are the same, right? So if you are going to remove, let's see, taking the same compound. So CH3, C, Br, H, CH2, CH3. So I'm using alcoholic KOH, which is the appropriate reagent to remove an XX, means a hydrohalogen we can remove using alcoholic KOH. See here, same way implies in the opposite way. The carbon, the hydrogen has to be removed from the carbon which has the lowest amount of hydrogen among the two carbons here on the either side. So in this carbon we have one bromine. On the other side we have a carbon with 2 hydrogen. On the other side we have a carbon with 3 hydrogen. So which one will go first is this carbon according to Markovnikov rule. So according to rule of elimination, the carbon which has the lowest hydrogen, from that carbon only you have to remove that hydrogen. So how the compound will come? Then CH3, CH double bond CH. Yes, so this is the compound that will be formed. So same way can be implied if you put, this is for Markovnikov rule. This is for Markovnikov rule. So this is going to be the major product. Let's say if by using the same reagent, I'm going to move against the Markovnikov rule. So what I have to do? Put an organic peroxide or hydrogen peroxide to the case. So how it will come? The carbon which has the highest amount of hydrogen, to that hydrogen only what will come? I mean, the carbon which has the lowest amount of hydrogen, in that hydrogen only what will come? The H will go. So understood? So among these two, the one which has highest hydrogen only, highest hydrogen within those carbon only, we give H. But according to anti-Markovnikov rule, so same reagent, but you use ROR, which is organic peroxide or hydrogen peroxide. So they are in that case here, the lowest carbon will get the lowest hydrogen, lowest carbon will get the hydrogen. Rest of the carbon will get the OH. So how will it go? CH3, CH2, CH2, OH. So this is the anti-Markovnikov rule. This two applies for Markovnikov rule. Same thing you can do if you have R or peroxide. So we'll come to the other side. Right? If you use alcoholic KOH with ROOR or hydrogen peroxide, you can get CH2 double bond CH, CH2, CH3. This two all belongs to Markovnikov rule. So you need to know the rules when studying the organic chemistry parts. It's a very must thing and you have to know it. Right. So this is the main concept here. So this is the main concept. Right. In this way, I have done. So you can remove water in this case, in this other way. So to form this, right? To form this, form this compound, what I can do is I can reduce it directly from here. I can bring ketone to alcohol by using what reagent? I can either use NaBH for methanol or simply NaBH4, or I can use the strongest reducing. I can use the strongest reducing reagent. It is lithium aluminium hydride with second step H plus H2O. So once you're using this reagent, lithium aluminium hydride, you have to put in second step H plus H2O. This is the must. Only for this case. For NaBH for methanol, no problem. Even though if you write NaBH for itself, you will get marks. That is not an issue. So this ketone will go to OH here. Okay. This is one method. Right? Same way, I can bring this bromine here to OH. I cannot directly bring this fellow to this ketone here. I have to go another step. So I have to go here like this. So for this, what I can do to convert OH to Br, I can add PBr3, right? It is going to get OH with PBr3, right? If you add PBr3, you can get. Or else you can use con HBr, very much highly concentrated HBr. So you can convert them also. So this is the most prevalent one. You can use this. So this is also the easier. Now see here, they have given the question in the 3 steps. I mean, 2 steps they have given the reaction here. You need an intermediate product here. Now see, once I went through bromine, once I went through this halogen, I got 3 steps here. 1, 2, and 3. But once I came directly to alcohol, then I came here. Here I used only 2 steps. The one which has the shortest step is the most appropriate one. Accordingly, you see the arrows. You have 2 steps here. I got 2 steps here. So this is the best one, right? So what I can use for the reagent? For the R, I can use con H2SO4 and heat. I can use either this or this. Not a problem. So what is going to, but what is the product which I'm going to get? So this like CH3, CH, CH2, CH3, this is OH. Right? You guys can ask me, why can't OH come here? No problem. You can write it either in this way, or you can write it like this. CH3, CH2, CH, CH. You can write it in this way also. Not at all an issue. Whatever way you write, it's going to be the same. Okay. Okay, so we use NaBH for methanol. So we can use OQ NaBH for methanol. So this is the best idea I got. Right? So we finally found out this is the best value, right? Okay. Now see here. Now see here. So in the same case, now see here. Once you check the reagent, now see the reagent here. Now see here the reagent. So DIL H2SO4, HgSO4. This reagent is only there in whom? Only alkynes. So we have only alkynes. Alkynes mean whom? C triple bond C. Only to these people only we have triple bonds. Right? Only we have triple bonds here. So that triple bond can be either in this side or in this side. Whatever side is there, it's okay. Yeah, whatever side is there, it's okay. Why I'm saying it? Let's see. Let's say, right? Let's say I'm going to break this part, okay? So either now see either if I have C triple bond C, okay, I'll be writing another marker. Okay. Let's say I'm having HC triple bond C, CH2, CH3 over here, and or I'm having this compound CH3, C triple bond C, CH3. What I'm going to do is HgSO4 dilute HgSO4 H2SO4. Now see here Markovnikov rule doesn't apply actually because you don't have any hydrogen here. Both the carbons you don't have any hydrogen, so you can put to any carbon. You can put to either this carbon or this carbon. Anyway, the compound is going to be same, just like this. Understood? It can be either this way or this way. Not a problem. But see here, which carbon has the highest amount of hydrogen among these two carbons? This terminal carbon will have the highest amount of hydrogen. So here you don't have any hydrogen. Here you have one hydrogen. So according to Markovnikov rule, if you add, this is hydration, okay? If you add H here, double bond. If you put another H here, this bond will become single bond. So OH will come here and here. So here decondensation. Condensation reaction will take place. So therefore, the ketone will be forming this way. Right? So not a problem. Now see, from here only the problem will start. From here only the problem will start. Now see here. Here you need to have an initiator. You need to have an initiator. Right? You need to have an initiator. Here you need to bring this compound. This intermediate has to bring this compound over here. Either one or two. Right? Either one of these cases to happen. So for these people, right? For these people, either you can bring it into two methods. Like you can either bring them like this. Like if you can remove water, right? And using dehydrating agent, so H2SO4. So forth. So if I dehydrate from ketone, let's say for example, CH, right? CH2, CH3. So CH2 will come here. So here OH, and here you will have an OH here. Right? Here OH and another OH here. I can use this reagent to get this, right? Or for this fellow, it will be like this: CH3, CH3. So it will be like OH and OH here. So this can be either my intermediate. So this is the answer here. This can be my intermediate. But see here, I have a problem. Here bromine is there. Here bromine is there. Right? Here bromine is there. So this bromine cannot be directly converted to OH. This has to go another several step. Okay? This has to go another several step. Like we need to go around 2 or 3 steps to come to the initiate. So according to me, I will stop here because after this part, I cannot proceed. So I need to find another alternate. So that has come confirmed. That has come confirmed. right? Now see, what I'm going to do is, I just found out, let the initiator be like either, let's see it was like CH2 double bond CH2 CH3. Let the initiator be like this. It's just an idea. So otherwise, let it be like CH3 CH double bond CH3. What I'm going to do is I'm going to add some bromine. I'm going to add bromine. So bromination is there in alkene. Alkene. So both the carbons will get bromine here. So it will come like this. So it will come like CH2 CH2 CH3. So bromine will come here. Bromine. Or right.